welcome back to the channel Maths with Berlin. So this is a video which is on complex numbers and trigonometry combined. So basically these chapters that are complex numbers and trigonometry are considered as very difficult by most of the students, but believe me, these chapters are not so difficult. So today we have two problems with us, that is basically on summation and product of the following terms, that is tan square of r pi by 17, where r is ranging from r equal to 1 to 8. Now those who want to give this problem a try, they can pause the video right here and give it a try, and for those who have given it a try or want to see the solution, they can move ahead. So basically in this problem, if you see what is the motive or what is the thought process generated here, is that we need to think about an equation so that we can try to find out this one as well as this one in one single work, right? We don't have to think about any other terms or any other ways out. If we can find an equation whose roots are tan square r pi by 17, right? If the roots are tan square r pi by 17, we can totally find out the value of the product as well as the value of the sum by the Veda's theorem, right? Now moving on to the solution. So basically there are a lot of things written on the board. Just follow my lead and it will be very easy for you all. So what I have done basically is I have just simplified the Euler form of the complex number so that those who don't know about it, they can be very much familiar with it. Now what I have done is I have tried to open up this binomial, right, after that, and right after that I have compared it with this part, that is sine of 17 theta, right? Now how can we compare? We can compare the imaginary part with the imaginary part of the binomials. So how do we get the imaginary part of binomial? Suppose that we get one out of, like, see, there are, think of it as like this, like how I think about it is there are 17 brackets, right, containing some real part and some imaginary part, right? So what I can do is I can take one imaginary part and take all the other real parts. What else can I do is I can take 3 imaginary parts and I can take all the rest as real parts. So that is the basic thing that we can do. Now if you take 3 imaginary parts, then you will end up with a negative sign along with the imaginary part, right, minus of iota. And if you take one imaginary part, you will end up with plus iota, right? These are some basic things that you need to know before proceeding with the solution, right? Now moving on to this next part of the solution, that is what I have done is I have written down the values as follows, right? Just what I have explained right now. After that, what I have done is I have put the value of theta equal to r pi by 17. Acha, before that, what else I have done is, let me explain this part also. I have taken this term outside, this term that is there in the first part, I have taken this outside of the bracket, right? So that helps me, because after that, if you see all the terms that are there after this, that is this term and all the others that are there, that gets converted into the format of tan square. This becomes tan square of theta, this becomes 10 to the power 4 theta, and so on up to 10 to the power 16 of theta. Now if I take the value of x equal to tan squared theta, so can you understand that the value of x, if it is taken to be tan squared theta, this is the value of x, this is the value of x squared, and so on up to the value of x to the power 8. Now we really got an equation in terms of tan squared theta, where theta equal to r pi by 17. So how do we, why do we put r pi by 17 theta, is that you can very easily understand when we put theta equal to r pi by 17, it will be this term that is there, that will become sine of r pi. Now sine of r pi, when r is a integer, as you can see there are all integers, this will be equal to 0. Now here that is what I have written on the left hand side of the next equation. So after that, what is there is very easy, and you can just solve it on your own by the help of Veda's theorem. So I have just written down the answers to the problem, that is 126 and 17. Now before moving on to the outro part of the video, I will share a homework problem with you all, right? This homework problem you all must try it, and please give your answers that you find, or have a good discussion in the comment section, so that you can increase your knowledge from the comments as well. So this is the homework problem for you all. See, in the question that is there in the video, we all solved for tan squared theta, and in the homework problem we are giving it for cos squared theta, and it is a more general derivation, and that is for n equal to odd, as you can see. So the solution to this will be provided in the next video, right? That will be there. So thank you for being with me here, and please do like, share and subscribe the channel, and share it with your peers, so that they can also benefit it from here. So that's it for today. Thank you everyone.